video, we're going to look at an object being launched into the air. So let's go ahead and read this first. The height h of t, by the way, that's in functional notation, in feet, of an airborne t-shirt t seconds after being launched can be approximated by h of t, there's a formula, negative t squared plus 90t plus 10, where t is between 0 and 10. That means that t is time in seconds, so that the time is between 0 and 10 seconds. Find the times when the t-shirt will reach a fan 130 feet above the ground. The first thing to notice in this word problem is they give you the formula. So let's go ahead and write that down first. Now, the goal of word problems that they already give you the formula is basically just figure out what the variables represent and be able to answer the question. So, what do our variables represent? Let's write that down. H of t, they say, is the height. And you can call it h. It's the height in feet of the t-shirt. T, they tell you, is the time in seconds after being launched. If you look at the question, it says, at what times? So we're asking ourselves, at what time? That's what we're asking. Right? Find the times. So we don't know that, so I'll put a big question mark there. Find the times when the t-shirt will reach a fan, okay, at 130 feet above ground. 130 feet is the height. So we know the height is 130. So all they expect you to do here is to plug in 130 for the height. So that would be 130 equals negative 15 t squared plus 90t plus 10. Okay, so that is our first step. Now, this is a polynomial equation, which is what we're solving, and it has degree 2. So I know how to solve that. I can solve this by factoring and use the zero factor principle. So that's what we're going to do next. But to solve that, I need to get a 0. So I'm going to get a 0 next. To set the equation to 0, I am going to get rid of this 130. So I'm going to subtract 130 from both sides to get 0 equals negative 15 t squared plus 90t. And then this would be subtracting 30, so it would be negative 120. That's our first step. My second step is to factor. So that's what I'm going to do. Before I go for the factoring into two binomials, I do notice that there's something common in each. Because if we look at what 15 times 6 is, 15 times 6, that is 90. 15, by the way, times 8 is 120. So we know 15 goes into all three of these equations. So I'm going to factor out a negative 15. So I'm going to keep my 0 alone. The reason I'm going to, well, 15 is common, that's why I'm taking out 15. The reason I'm taking out a negative is also when I'm factoring a trinomial, which is going to really help to factor out the 15, by the way, because it's going to get these numbers smaller. But I do not like the first term to be negative. I think it's really tough to try to factor trinomials when the first term is negative. So that's why I'm taking out a negative 15 as well. So I'm just going to divide a negative 15 in each of these. So this would be a t squared. This would be a, we're doing a negative 15. So this would be a negative 6t. Negative 15 into this one would be a 8 plus 8. So now I factored out a negative 15 in all three of those. But I can continue factoring. The inside is a trinomial, and it can be factored into two binomials. So let's go ahead and do that. We know that this represents, by the way, the first, right, when we're doing FOIL, backwards FOIL, we're doing it right now, this represents the last. So we know that this is the first is going to better be a t and a t, and the last better be factors of 8. So you could do 1 or 8 or 2 or 4. I'll try 2 and 4 first. And then we need to somehow get the inner, outer plus the inner is where the 6 comes from when we're doing FOIL. So somehow when we do FOIL here, because we're going backwards, we need to get a -6. So you can see the first terms get t squared, the last terms get 8, so now we're just into the -6. So if we make both of these negative, and then you look at the inner and the outer, that would be -2 with a -4 would indeed make a -6. So that is how we factor that trinomial. Okay, step 3. Step 3 was our whole goal, use that zero factor principle. If the zero factor principle says if you have two things that are multiplied together that are 0, which by the way we do, we actually have 3, then the first one equals 0 or the second one equals 0. Okay, so I'm going to set each of these factors to 0. The -15, by the way, can be ignored because -15 is never 0. There's no variable there. If there was a -15t, then you would need to use that one as well. So we're going to have just t minus 2 equals 0, or t minus 4 equals 0. Those are the two factors. If you're really bugged by the -15, you could have divided both sides by -15 to just get rid of it. That's one way. Or you could use this as the first factor, and you can see we'd get -15 plus 30, and you'd still get the same answer, which is t equals 2, because adding 2 to both sides, these are both linear. And those are our two answers, and the time is in seconds. So we know that it hits the ground in 2 seconds. And the next one is 4 seconds. And they ask you to separate a comma, so 2, 4 would be your answer. If you would like to see a visual of this, if you notice when it starts at 0 seconds, when t equals 0, we are 10 feet above the ground. So let's call that 10 right there. And then it takes off. The t-shirt gets launched into the air. And then 2 seconds, the t-shirt is going to be at 130. I know that's not to scale. And again at 4 seconds, I'm going to have to redo let me redraw it. Okay, so here's what it looks like. The t-shirt is being thrown up in the air, and 2 seconds after, it's going to be about 130. And then why is there's two answers? Is it because it keeps on going up, and then again on the way down at 4 seconds, it's also at 130 again. So that kind of gives you a picture of what's going on with our t-shirt. Hope that helps.